Hello everyone, I'm going to present a new topic in that special lecture on semiconducting physics. It's a special topic, the Hall effect. It is most important one that will be used in various industrial applications as well as modern technological tools. So now, what is Hall effect? These are the content that I'm going to present in this video. First, discovery about the Hall effect. Second, what is the physics behind the Hall effect? Third one is application. Fourth one is some personal experiment related with this real-time application related with Hall effect. So what is Hall effect? It was discovered by Edwin Herbert Hall. First it observed in the year of 1879. So what is the key effect here, key parameter that it was? So it is only the properties is nothing but Hall effect is morely related with the movement of the charged particles, that is electron. But this effect was discovered before the invention, before the discovery of the electron, before the 18 years before the discovery of the electron. So that was the beauty of this Hall effect. So what is the principle? Main principle is behind that the mobile charge is present in one side from the Lorentz force. At another side is another side of a material. Immobile charges are unaltered. That will be in the stable. So that will be the main classical idea about the Hall effect. It is nothing but when the charge particle placed on a particular area and a magnetic field, the electric charge particles cannot divert to the one end. Another particle can be diverted to the another end. The potential difference between the two phases being given the potential difference, that is called as Hall voltage in this real-time applications. So that's Hall creates internal electric potential known as Hall voltage. So what is the simple for this for both? It was affected for both metal and semiconductor. So we have for metal we have to derive the equation. Suppose Hall voltage is represented by V, that is equal to I, that is current, and product of with B, the magnetic field B, and the number of particles, and E electric charge, and T is the thickness of the material. So that will be the key for the Hall voltage, determination of Hall voltage across the junction of the metal pieces. What is the principles? This is a principle. This is a visual representation about the Hall effect instrumentation setup. So what is that means? You can see that it is a piece of material placed in the horizontally. So it is was electric field applied on one direction. Perpendicular that the magnetic field applied on perpendicular to the applied electric field. So the charged particles can separated by two ends of the materials, like F1, F2 means if we refer the any by naming, we have to name as a phase 1 for a positive, phase 2 for a negative. You can see that the charged particles are accumulated one end, another charged particles, opposite sign of charged particle accumulated in the opposite side. So you can see that the magnetic field deflects the electrocharged particles into one end because of the Lorentz force. So that will create the potential difference between the two junctions. So what is that effect means? If it is a material or a metal or a semiconductor placed in a magnetic field with applied current voltage, the charged particles accumulated are charged particles accumulated opposite side. So both that will create a electric potential that is called as a Hall effect. So this is for the main classical principle behind the Hall effect. So you can see that this is from the and dusted this NDT techniques. This is a setup to the NDT technique means a non-destructive technique that to analyze the properties of the material without damaging any of in a test and the quality checking process. So manufacturing industry that were using like that of NDT technique to analyze the breakage or flaws in the development product or material. So these are the classical equations for the Hall effect, that is denoted by the symbol RH. So there is a magnetic parameter in metals. RH is equal to EY, JX and BZ. In semiconductor, RH will be given by the chemical that is a P-type and N-type material. Semiconductor is classified mainly. Hall effect is to determine where the material belongs to P-type or N material. From that, from the experimental setup, we have to identify the material. So with the which material will be belongs to N-type or B-type. If it's a Hall voltage means if a material placed on an electric field, the negative voltage is produced by the Hall voltage. It is belongs to n-type material. If it is Hall voltage is indicated the positive means it will belongs to p-type semiconductor. So what is the Trump? That is what's behind the electrical Hall effect. The classical is the only electron moving the same average direction in both hole p-type and n-type conductivity, but opposite sign indicates that electrons and valence band moves in the opposite end than previously taught. So that was the real one. So what is the application of this Hall effect is the measurement can tell about the charge case mobility and concentration, how much is accumulated in one side and opposite side. So that will be given the more potential differences. Conversely, knowing the above of all sensitive instrumentation of external B field, some of the so that we have to use for electronic switching devices. Some variation produced by the magnetic field, it is produces small deflection in the electric current that will be acting as a switch in various electronic devices and resistant to outside contaminants and in optical electro-optical testings. So these are the main applications that will be used in various industrial application. Next class we have to for physical. Next topic will be the more futuristic potential application we will discuss in the next class. These are the summary of my classes. So this is the physics of Hall effect. I'm here as a short intro about the what is the classical physics will be behind it, and future popular application we have noted, and future application will be discussed in the next class.